System of inequalities. So we're going to have to start off with something easy and build our way up. Kind of like when we did inequalities with the brackets and parentheses. I showed you how to do it on a number line first. So this is kind of similar in a weird way. If we have a coordinate system, x, y axis, and I want to graph this inequality, x is greater or equal to -3, then it is not just a solid point with an arrow pointing to the right. That would be just if it was the x-axis alone. Since we're in a coordinate space, we have to account for all the points whose x-coordinate is -3 or above. So the first thing you're going to draw in is the line x equals -3. Because it's equal, we're going to draw it as a solid line. So x equals -3 is a vertical line that goes through -3 on the x-axis. So where are the coordinates where the x-coordinate of each one of the points is bigger than -3? Are they over here? Are they over here? Yeah. So if they're to the right of the line, it's all of the points to the right of the line. So we shade that side of the line. So it's all the points to the right of this line are a solution to this inequality. How many points are there? An infinite number of them. Lots and lots. So that would be the graph of x is greater than or equal to -3. All right. Keep it simple for one more. If we have a coordinate system, and I want to graph y is less than 4, how would I draw it? Now, what kind of graph is y equals 4?
Horizontal.
It's a horizontal line. But because it's not equal to it, it's strictly just less than. Instead of a solid line, we're going to use dotted line. So y equals 4 looks something like this. Because it's not strictly equal to, it's just going to be a dotted line. Horizontal line going through y equals 4 on the y-axis. When we're talking about less than 4, what side of the line are we talking about? The top or the bottom? The bottom. So all of these points will become solutions, but not the points on the line. So it's all the points below the line, literally here. Where the first one was, it was a line or all the points to the right of it. This one is literally all the points below the line are the solution set points of y is less than 4. Okay. So what about a line with a slope and a y-intercept? Now the first thing you have to decide is how are you going to draw the line? Solid or dotted? Solid. What's the y-intercept of this line?
-4.
Where does it go?
The bottom.
The bottom, so it goes down 4 from the origin, so it'll probably be about there. There's -4. What's the slope? 3 over 1. So from -4, 0 to -4, where would you go?
Up 3.
Up 3 and over 1. So you'd probably get a point here, up 3 and over 1. And we've already decided that it's a solid line. So the biggest mistake here is most people just draw the line first and don't think about it, and then they look back at the inequality. If you do this in pencil, that's okay, because you just have to erase every once in a while. But if you remember to do it from the beginning, it makes life a little bit easier. So this is part of our solution. Solid line going along 3x minus 4. Now deciding what side of the graph you want to shade is a little bit different. So I want to do this slightly different than the other two. The other two are quite obvious. When you're dealing with a slanted line, whose slope is neither undefined nor 0. The way I like looking at it is you go to the y-intercept. This is talking about y, and y is always up or down. So from the y-intercept, what is greater than? Which side of that red circle would I go on? There's no right and left here.
On the top.
You would go up, right? So to go greater than on the y-axis is this side. So that's the side of the line you have to shade. So when we look at it, you go to the y-intercept and you either just go up the axis for greater than or down the axis for less than, and whatever side of the line that ends up on being, then you just shade that side of the line. So all the solution set would be all these points. Okay. Now so far this is just inequality graphing. This is not a system of inequalities. To make it a system, you'd have to incorporate 2 lines, and I'm just building up to how we're going to shade these things in. All right, let's try one more. How about y is strictly less than negative 1/5 x plus 2. Okay. So what's the y-intercept? 2, so that'd be 2 up. The slope is?
-1/5.
So I'm going to go down 1.
Over.
Which way? When you say over? Okay, I got right from Michaela, left from Anjali. Which one is it? What? Dang it, I was hoping you'd say right. Down 1 is the negative part of it. So if you go back 5 to the left, it's negative over negative, which makes it positive, and you don't want to do that. You want to make sure it goes down and to the right 5, so that the slope of the line is negative. The other thing you could do is go up 1 and back 5. Therefore, the up is the positive and the back 5 is the negative, keeping the slope negative. Now, how am I going to draw the line through those 3 points that probably don't even line up really nicely? They don't. That's a little bit better. So how am I going to draw a line through them? Dotted, because it's not equal to, it's just strictly less than. And if you don't remember, just go through with an eraser later and get rid of it. All right. Then use the little trick. Go to the y-intercept. And from the y-intercept, you just choose whether you're going to go up or down with your shading. So this is y is less than, so which way do you go? Down. So you're going to shade this side of the line, and these are all the solutions, minus the line, of that inequality. Isn't that nice and easy? In other words, this lesson's going to be over in another 10 minutes. And we can go play on the computer or do some work in class, one of the two. All right, so let's put it all together into inequalities. Now there's 2 methods. I have a preferred method, and then the book does it a different way. So it's up to you how you do it on the test, but you have to tell me which way you're doing it. There's the forward method, which is that, or the backwards method. And the backwards method is, sure, this says y is greater than, stop it. And you're going to shade the top part of the line, but reverse method would mean you would shade opposite of it. And there's a reason you would do opposite of it, and I'll show you why in a second. So, what would you do first here?
Get the second one in y equals.
Get the second one into y equals slope-intercept form. All right, so this becomes 3y is less than
5 minus 2x.
Would you write it that way?
Negative 2x.
I mean, it really doesn't matter as long as you remember that the negative 2x is the slope part. Plus 5.
And then divide by 3.
Flip the inequality or no?
No, because it's not negative.
Because it's not negative. Okay. So this is one of the lines we're going to graph. Wow, this is squeaky. And this is the other. So get them on a piece of graph paper or a coordinate grid. I'm not looking for perfection in the graphs. I'm looking for accuracy up to a point. Slope going in the right direction, the y-intercept in the right location, and the shading in the...
I have not done anything.
Death. So, how do I graph the first one?
-1 is the y-intercept.
So, down 1.
Down 1,
Slope,
up 2 over 1,
up 2 over 1. Kind of line?
positive.
No.
Oh, solid.
Solid or dotted, shaded if
Solid.
you want to think of it that way.
Solid.
Solid as a rock. So, down. Oh, that's horrible. Life goes on. Alright, the other line.
Dotted.
Dotted, slope intercept, or I'm sorry, y-intercept.
Positive 5/3.
Positive 5/3. That's what? 1 2/3, right about there. Slope?
-2/3. So down 2, right 3.
Down 2. So this is up 1 1/3. So down 2 would be a little bit below the x-axis, and right 3. Right about there. And this will be dotted. Okay. Then all your focus turns just to those y-intercepts and the inequalities associated with them. So if we're looking at this y-intercept, the -1, it says greater than equal to. So I'll do this forward and then I'll do it backwards and show you the difference, and you'll see the difference better because you do it in one color where I'm doing it in 2. So color pencils come in handy if you want to do forward shading. So since it is greater than, you go to the y-intercept and you're going to shade greater than that point. Oh dear God. So
Come on, I've never done anything like that.
Christmas tree.
Okay.
So you shade the side of the line. Actually, I need you here for a little bit longer. Then I can kick you out. Voila. So, next one. The 5/3 one, this one. What side would you shade on that one?
The bottom.
Down. So, from the line down this way, you would shade in this direction, from that dotted line. And this is where it gets messy. Your solution is the intersection of these two colors, which is really hard to see if you're just doing it in pencil. So reverse shading is another alternative, and I like it a lot better because sometimes you have a system of 3 inequalities, and finding where 3 shades come together is really hard. So if you do reverse shading, the answer actually becomes really clear. So here, the answer is over here in this mess, which is really hard to distinguish. The boundaries of it are hard to distinguish, and where the solution really is very difficult to distinguish. So I'm going to draw the lines rather quickly. Here's the first one. Here's the second one. Something like this. And initially from the first one, we wanted to shade up. So the inequality said to go greater than, so that would be in that direction. But with reverse shading, you don't want to shade that side. You want to shade the opposite. So you're going to shade this side. And basically what you're saying is none of these points are solutions to that first inequality. So none of these points are part of our answer. In other words, you're getting rid of points instead of including points. All right, and then when you do the red one, or the, well, what's it on the screen? Is that red? Oh, that is red. When we do the red one, we're supposed to shade, it's less than, so down. But instead of shading down, we're going to do the opposite. Bless you. I don't know why I'm being polite to you. And we get that. And what I like about this is you see the boundaries for the answer very clearly. Oops, this is supposed to be dotted, the red line. Where the answer to this one, the boundaries are really kind of lost inside of the shading. The reverse shading leaves it completely blank, and you can see the boundaries very clearly, that the red line is a boundary at the top, and the blue line is a boundary at the bottom. And your answer would be in the empty space. And that's why I like reverse shading better. So it's up to you if you want to do forward shading like the book, but they have colors, so it comes in handy. But even with colors, the boundaries of it are very messed up. I don't like it. So if you do reverse shading, your answer is just the empty space. And it's very clear where it is.
Oh.
Just a thought.